voice check, video check. Good morning, everyone. Welcome to another episode of XahTalk Show. Today we are going to do Wolfram Language Mathematica coding. Fantastic. And I'm going to code Emacs Lisp. I'm going to write a major mod for Wolfram Language. You see this beautiful torus, beautiful. So let's begin. So head count. Good morning, Bart. Good morning. Mining God Bruce. And good morning, Zitron Crazy and Celtic Orthodox. And okay. So if you comment and questions, okay, I love see your comments. Comments get me talking. So we are going to do Wolfram Language. So first of all, I'm going to tell you. Let's dive into explore the realm of mathematics, parametric plot. Okay, surfaces. I'm going to explain parametric plot and show you some great features of Wolfram language I discovered yesterday. You know, it's been a long time hiatus. I haven't been really coded Wolfram language for 20 years. In the 1990s, I was one of the great experts of Wolfram language. But thank you, Cortez. God bless you. Thank you, Cortez, for the donation. And so Wolfram language, I haven't been really, in the 1990s, I code almost every day, for several hours. I'm a master of Wolfram language, but it's been 20 years, and 20 years, so much has happened. And, Wolfram language, and to this day, back in 1990s, Wolfram language is the greatest language beyond them all. In the 1990s, you don't have that much. Okay, the most highest level language is Perl. Perl, that's it. But today Wolfram language is still a magnitude beyond all languages. Haskell, Erlang, all the fancy languages, Haskell, Erlang, Golang, a magnitude beyond, not just twice, three times, a magnitude, it's highest level possible. In fact, like I said before, watch my YouTube about 3 or 4 months ago. I did some 5 videos on Wolfram language. Okay, I give you in depth many perspectives on what is the Wolfram language. Why is it great? Okay, so why is it magnitude? So one way you can consider Wolfram language to be the artificial intelligence language built-in, like. Today Google has a lot of libraries, right? Libraries for AI, Tensor, TensorFlow, whatever crap. Google, they are pretty good. They build the, Google is the empire today, the empire on earth. But you have to be a programmer. You have to learn, neural networks. What it is, you have to learn. You have to spend years to study all these things in order to be able to use the Google's, AI library or image recognition and so on. But in Wolfram language, it's all built in. You can okay, I'm not. That's a digression into AI, but I'm just going to show you. For image recognition, for example, is part of the built-in. You just call a function in Wolfram language. Okay, I'm not going to go over it. Anyway, digression. So I'm going to show you some of the parametric plot feature I discovered yesterday, and let's start Wolfram language. Okay, and so some part of mathematics and about yesterday we did spheres. So part of mathematics and also okay. So let's what is parametric surface? Okay, that's what I'm going to explain today. Part of mathematics. Okay, then show a feature of Wolfram language that plots parametric surface. Can you see it? Magnify. That plots parametric surface of a specific region. Okay, arbitrary region. Why? How does that work? What does that mean? I'm going to explain. Okay, show a feature of Wolfram language that plots parametric surface of a given region of any shape. Okay, that's the key, any shape, because normally when you think a mathematician, when they think of parametric surface, you have a parametric formula, parametric equation. You think you begin the domain, when you have a function, you have the domain and range. Domain is where the beginning, where you begin. Range is the output. Okay, so domain is for a parametric surface is usually a square. Okay, a rectangle, not necessarily square, a rectangle. But with Wolfram language, this feature, it needs not be a rectangle. It can be a triangle, it can be a circle, and it can be a stripe. It can be a circle with a hole. It can be arbitrary shape. That's the power of this feature I'm going to show you. Okay. Good morning, Winnie. Mathematicians love torus-shaped pastries. Yes, indeed. Okay, I'm going to show you. And so, what is parametric surface? I'm going to demonstrate using Wolfram language, and I'm going to show you this particular feature of Wolfram language of plotting parametric surface of a given arbitrary shaped domain. Okay, then I'm going to write. Then it's Emacs lisp time. I'm starting to do a lot of Wolfram language coding, and I need to code it inside Emacs lisp. Write a Emacs major mod for Wolfram language. Okay, so soon we are going to have, you will be able to download for free, work on Wolfram language. And before we go, forgot, let me mention, you go to my website, Wolfram language is for free. Okay, they gave me a copy. So you go to Wolfram language website and you go, there are several videos I did. These are great. Okay, I recommend you watch it for science sake. Okay, get yourself to know some science and mathematics, not just programming, the idiotic C and Unix crap. Okay, get to know mathematics and get to know Wolfram language. It gives you a far more different perspective than Lisp. Okay, than Lisp or Haskell. Okay, Lisp and Haskell, they are not comparable at all. Okay, so watch these videos. I give you several perspectives on Wolfram language. And there's more, but I didn't put it here. But anyway, here is the download Wolfram language for free. You can get it free from if you buy a Raspberry Pi, or you can download Wolfram Engine, or you can download Wolfram Script. Wolfram Script is when you want to use PowerShell. For example, I'm using PowerShell here. When you, or PowerShell or Bash or TC shell or Z shell or whatever shell, fish shell, there's Unix crap. Now, if you want a shell scripting language that's a magnitude more powerful, for example, you can construct, even Scheme shell. Scheme Lisp has a shell called Scheme shell. It's old news. It's been dead for like 10 years. But whatever shell, Wolfram language has Wolfram script, which is just like a shell, okay? So, but instead of using Bash or whatever, you use the Wolfram language syntax to do sysadmin, okay? That's what Wolfram script is. You can download for free here. Okay, so that's about that, okay? So, but let's begin the talking of the mathematics, okay? So let me show you a parametric surface. Can you do this same thing in GNU plot? GNU plot. No. GNU plot is the one of the worst fuck possible. I don't mean exaggeration. Okay, let's remove the drama. Okay, let me say this: GNU plot is truly one of the worst plotting software for mathematics. You can, there are so many. GNU plot is one of the worst, not just worst. Okay, the meaning of worst in English is the worst. Like you compare all, like there are literally hundreds of plotting software. I have a website that I talked about yesterday. Just go read my website, okay? I talked about. There are literally hundreds of plotting softwares, usually many of them written by university students, when they were young. When I was young, I wrote a few in Wolfram language, okay? So there are many for Windows, for Mac, okay? You compare, if you actually take the time to study all of them, GNU plot is one of the worst fuck possible. Fucking scum. in terms of quality. If you care about the design, about the power, about programming language design, about the elegance, about whatever, about the power, what it can do, GNU plot is one of the worst fuck. And it so happens, no surprise, to the Unix people and the Linux fuckheads. Every day they say is GNU plot, Sage Math, and the LaTeX. These idiots. Okay, so that's my opinion about GNU plot. Just go spend $300 for, if you want a student version. Go just it depends on what you want. What do you want in your life? Do you want to become a professional, become a mathematician, become a great programmer? Is that what your goal is in life? Or you rather prefer to spread the open source ideology? Like what is it you want? If you think for you to spreading GNU or ideology of the Free Software Foundation or open source, yeah, sure. Go or use Linux, use GNU plot, spend every day hours on it. First about nothing, much ado about nothing. That's your time, it's your choice. If you truly think, open source, and you will not be thanked. You are just a minion. You are just a minion in a million. Okay, so avoid, let's hope to avoid swearing, because Google is gonna, censor me, or Google is gonna, say my YouTube, a few days ago, last week or so, one of my YouTube is like flagged. This video is not suitable for advertisement. Fuck Google. Okay, and that video is nothing. It's just about math or something. Maybe I swear too much. Okay, so let's you help me avoid that. Okay, so okay, let's get on to the main topic, parametric plot. So what is parametric surface? Okay, so what is a parametric surface? This topic. Okay, that's what I'm gonna show you. So parametric surface, basically you have three functions. Okay. Let's write it. So when I write it down, it's slower for those of you watching my video, but however, it's more coherent, my whole video. If you watch offline, you can fast forward, or speed up 1.5 something. So parametric surface is a surface. Okay, I don't need to explain surface. Surface is just a surface. Okay, I mean, if you go to very technical mathematicians way, the surface is designed, is a surface in math is defined as a how do they define it? It's a it's not. I mean, I'm not. I haven't done math for a long time. But you go to go to Wikipedia and you'll see the official definition. Let's go to manifold. Okay, let's say manifold. So the proper name, the more general name, is manifold in mathematics. So you can see there it is. Wolfram. There's a Wikipedia. Okay, and this real projective plane, this surface is called Boy's surface. Okay. Yeah, so this surface is, I have a page of it. This surface is called Boy's surface. And this image is actually plotted in Wolfram language. This is pretty old. This is like 20 years old image. And I would actually presume this surface is actually from my website, from my professor, from my, I'm pretty sure they copied. That's the nature of Wikipedia. They grab things on the web. They don't have to copy my image. All they have to do is copy the formula. They plot it using Wolfram language. Then they put it here. Then it's part of Wikipedia. But anyway, okay, don't take my word for it. But anyway, I mean, this formula is public. Where do we get it? Did I get it? I got it from my professor friend. Where did he get it? He didn't invent this one. He's Richard Palais is my friend, my mentor in mathematics. He's one of the top differential geometers in the past 50 years or so, one of the top differential geometers. So, but anyway, this surface is Boy's surface. Okay, Wikipedia will give you information about who is the guy Boy's. Okay. Anyway, so digressions. Okay, manifold is a general name for surfaces of any dimension. In fact, a curve is actually also a manifold. A curve, a plane curve is also a manifold. It's just a one-dimensional manifold. Okay, so manifold is a general name for surfaces. Can be any dimension. So this surface, for example, we see that's a two-dimensional manifold because it's a surface like a paper. It's two-dimensional, x and y. But it can be three-dimensional thing. It can be four-dimensional. So study math, then you'll know. So where do they define? So one of the important thing about manifold is that they must be smooth. Okay, differential manifold. Okay, let's read it. Okay, in mathematics, a manifold is a topological space that locally resembles Euclidean space near each point. That's a bit complicated way to, if you haven't studied math, you have no idea what he's talking about. And it says, more precisely, an n-dimensional manifold, or n-manifold for short, is a topological space with a property that each point has a neighborhood that is homeomorphic to an open subset of n-dimensional Euclidean space. Okay, that's kind of mouthy. Too many words. Okay, so what is a manifold? Manifold is just a surface. Okay, it's just a fucking surface, a smooth one. Okay, one of the important criteria, it must be a smooth one, because in algebraic geometry you can have surfaces that has kinks, like one sharp point or self cringes. Those are not considered manifold technically. Those are called algebraic varieties. Anyway, digressions. Okay, so surface, but so actually, I'm not a professional mathematician. I'm barely amateur. So don't take my words on math too much. Okay, you need to study. So anyway, manifold. Okay, we digressed. Yeah. So anyway, let's go back. So parametric surface is a surface that are defined by three equations of three functions. Okay, functions of two variables. Okay, so that's basically what a surface is, a parametric surface. So how do you define it? So you say it like that. Traditionally, you write it like this. Okay, let's type it fast. X, Y, Z, F, G, let's say F1, then F2, then F3. Okay, so in three-dimensional space we have three coordinates, X, Y, and Z. Okay, then you have three functions. Okay, actually this is incorrect. Let me correct it. U, V. Okay. So x, the value of x equals to a function of two variables, u and v, two parameters. Okay, this function returns one single number, and you assign this number to x. Okay, that's the x component of the coordinate, and same thing for y and z. So the thing you need to remember is that all these three functions, f1, f2, f3, each one of them takes two variables, u and v. Okay, and typically, so what we say is that u goes from, let's say, a or b, a to b. Let's say 0 to 10 to be concrete, and same thing, v goes to 0 to 10. So this is a domain. So what does that mean? So u and v are parameters. Just like a function. For example, let's say function x. If you want a bunch of values of this function, you need to give it many values of x. Let's say x from 0 to 10. 0, F0, F1, F2, so on. So you got a bunch of values. So in here, the parametric surface, you have three functions, F1, F2, F3. Each one takes two parameters. And the two parameters, the U goes from 0 to 10, and V also goes from 0 to 10, or whatever number, okay? Negative something to something, okay? So essentially, so anyway, so you for each value from 0 to 10 of U and V, you feed them into these three functions, and you get a point, X and Y and Z. And you plot that point in a three-dimensional space, okay? So after you plot all these infinite numbers, 0 to 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 0.1, 0.2, everything, then you got lots of XYZ points. Then they form a surface, okay? So let's, for example, let's start to write an example, okay? Let's see. So we have a example of a sphere of the easiest simple example is the torus, okay? Torus is very easy to illustrate. So let's evaluate it, okay? Let's evaluate it. So you got a torus, okay? And let's do this, okay? Let me show you how the parameters forms, okay? I did this yesterday. Okay, so R equals to 3. Let's not use the, so R is 3. So let's magnify so you can actually see better. So any comments, comment and questions? Sorry, Xah, no problem. What about what? Sorry, what? Hi, Xah, greetings from Peru. Jetwa. Donut. About donut? What about it? Go for it, homie. Cocoa points. Okay, whatever. So let's get back to the surface. Okay, let's remove the capital R, the variable. We don't want the variable, and remove the lowercase r, because let's just say it's constant. Okay. Okay, so there is our surface. Okay, let's now add some. So here is U. You see, I have a surface here. So again, like for example, let me show you what's going on. Okay. So you can let me prettify the code so you can actually see the syntax. You see, like we talked about, we said before, a surface is three functions, right? So there you have it, three functions, x, the f1, f2, and f3, and they take two parameters, u and v, okay, u and v. So now we need to say, the domain, u goes from, where to where, v goes from what value to what value. So that's what these two parts are. So here is u goes from 0 to 2 pi. Okay, so let me just plot it so you can see. Okay, so let's plot it here. So okay, so that's a parametric surface. Okay, but now what I want to do is that I want to do a dynamic visualization. Okay, so this is another great feature. This is a great feature of Wolfram language. So u, instead of u2 2 pi, let's say u2 variable u max. Okay, and for v also v goes from v to v max. And then okay, so watch the structure of this the syntax. Okay, so you have the parametric plot here, then you have manipulate. The first argument is a whatever expression. The second argument is gonna be u max from let's say 0 to 6. Okay, copy it, then we say the same thing, v max from 0 to 6. Okay, let's just show it. Okay, we got an error. Let's probably a typo. So what's going on? 126. So what is the error? Endpoint for you in that must have distinct machine precision values. Okay, whatever. Let's say 0.1. Okay, we have it. So actually now let's let's magnify. So so let's shrink this a little bit. So now let's increase U. So as we increase U, now this doesn't look so good. Okay, let me redo this so you can see what's going on. Because when you change the, you see one of the questions is, why is the graph kind of jumping around? You know, why is the graph jumping around? I don't want the whole frame to jump around. I just want to see the tube go around, you know. So the reason it's jumping around is because every time Wolfram Language plots something, it shows you the best choice of perspective, you know, how far you are looking at the thing. So when your whole plot is just like that, Wolfram says that this is the best perspective. But when you have more stuff, you know, Wolfram says this is the best perspective. So in each frame, it changes, you know, the distance and angle you view the thing. So what we want is we want to fix the viewing angle. Okay, so we can do that by an option in the parametric plot. Okay, so what is the option? I don't remember. Let's see. Viewpoint. Okay, so there it is. Viewpoint. Let's say front. Okay, let's see what happens. So this is the option. Okay, that's not good. Okay, viewpoint. We don't want front. We want let's say, you know, Wolfram suggests several values. Let's say, what is the range here? So from 4 to 4. Okay, if we change this to 1, okay, now it's a fat donut without a hole. Closed hole. Asshole. Okay, let's see. Let's change the 2. Okay, this is good. So the value, so you can see the axis. So it's about 5 across. Okay, so let's see how far where do we want to view these things. So let's say 333. Okay, let's say 444. Okay, so viewpoint 444. You know, that's a point in space. Okay, that's no good. Okay, now we have fixed viewpoint, but why is it still jiggling around? Well, that is because, you know, why is it still jiggling around? That is because, okay, you have fixed viewpoint, so viewpoint doesn't change anymore. But however, it's still jiggling around because every time you plot, Wolfram Language also automatically decide, you know, by artificial intelligence, it figures out the best plot range. I mean, the best how much things you want to show, you know, in a plot. For example, when you don't have much things, you only show this part. It doesn't show the whole empty part. So we also want to fix the plot range. Okay, so let's fix it. Plot range. Okay. Okay, so we need to type this. This is tedious to type. Okay, plot range. You need to specify x, a range for x, a range for y, and a range for z. Okay, so x will be -3 to 3. Okay, and y will be -3 to 3. Same thing, and z will be, let's see, -1 to 1. Let's say -2 to 2. Okay. Okay. So now we have a fixed plot range. You know, don't automatically decide for me. I want it fixed. So let's do it. Okay. Now you see a fixed box, even there's nothing in it. So now you can see what. Okay, our viewing box is too small. Okay, we are not seeing the whole thing. So let's increase the range. I mean, increase the plot range. Okay, so let's say 4, -4 to 4, and 2 to the z from -2 to 2 is good enough. Do it. There we have it. Fantastic. Let's magnify this thing. Can we? Yeah. So you see, there we have it. There we have it. Let's see that, and that. You see? Fantastic. Now there's, okay, so what's my point? Okay, so in the past 5 minutes, I showed the technicality of using manipulate function in Wolfram language. So we first about it, we explained why viewpoint changes and so on. So now we got what we want. Okay, so now we got what we want basically. This and why are we showing this? Because this illustrates what is a parametric surface. You know, basically any parametric surface, it goes like this. Okay, 3 functions, 2 variables. Okay, but there's another thing I want to, about Wolfram language is because you see, when you manipulate it, it doesn't show the high resolution. Only when you stop it, it shows the high resolution. So how do I fix that? I don't know. I have to look up the, the documentation for manipulate. But that's not important for today. Let's worry about that. I have to worry about that later. So I have to read, spend 20 minutes to read the documentation, for the manipulate function, so that, okay, so the point is, so this is about parametric surface. And the one thing I really want to tell you guys is that this is about mathematics. Okay, so parametric surface. Now remember, so U and V has a range, U 0 to 10, 0 to 10. So essentially U and V, they are just a rectangle. Okay, imagine the U axis, okay, 0 to 10, and the V axis 0 to 10. So U and V, actually they are just a patch of rectangle on a plane. Okay, like this paper, so this is U 0 to 10, and this is V 0 to 10. They are actually just a plane. And these 3 functions, x, y, z of 2 variables, f1, f2, f3, these 3 functions are taking, essentially what they are doing is that, so this is a geometric perspective. They are taking points from this plane, this rectangle. They transform this rectangle into a torus. Okay, that's what they are. That's what happens. Okay, that's what every parametric surface is about. They are taking a rectangular. They are transforming a plane, a rectangle, into a surface. Okay, including this one. Yeah, I believe that's including this surface, including, so yeah, here you see, here they show the parametric formula for this surface, which, again, each one has 2 variables. In this case it's a bit more complex. They goes into the the complex numbers, but essentially it's the same. 3 functions and 2 inputs, U and V. In the case here, the U and V, I believe they are imaginary part of the complex number and the real part of the complex number. It's the same thing. Okay, you can rewrite this formula without complex numbers. Yeah, I'm pretty sure. Yeah, the W is a complex number. So anyway, so that's the first point. I hope I hope that's a good explanation of parametric surface to any people who are not, who haven't studied math that much. Did I do a good job? Is it successful? Okay, that's one break. Now we can go on to the next topic. So how long have I been talking? Oh, 40 minutes, almost 30 minutes. Okay, let's sip a drink. We are almost done. Okay, actually, so today's talk show, we completed explanation of a parametric surface, which is essentially, from technical point, it's 3 functions. Each function takes 2 variables, and then you specify the range of the variable. Then you get a surface. That's a technical perspective. The kind of the essential, the math perspective is that it essentially transforms a rectangular patch or plane into a surface. Okay. Now the next time, okay, so that gives that. So now we're gonna explain the next thing. Okay, let's make this. Okay, so now we are going to explain the next thing. So we explained the first thing, what is a parametric surface. The next thing is show a feature of Wolfram language that plots parametric surface of a given region of any shape, not just a rectangular patch, no more. So that's the next thing. Comments? No comments. Comment. Okay, actually, so before we do anything, let's I need to show some spectacular image on my screen so that Google can pick it up. So actually, this is the one I'm going to show. Okay, so let's go back to Wolfram language, save it, and let's paste it here. And look at this spectacular image. Now, what are you looking at? Let me explain, okay? You see, before, we did this whole parametric formula thing. We did the whole tube donut thing, okay? So you can see, as we vary the parameters, it generates the donut, okay? Complete donut, okay? Not complete because our maximal value is 6. Now, if we change it to pi, which is 2 pi, so 1 pi is 3.1456, okay? So 2 pi is 6.28, okay? 6.28, something like that. Or I can just type 2 pi, okay? 2 pi. Okay, so that's U max, okay? Now V max is also 2 pi. Let's do it. So now if we do this, and if we do this, you can see, if we close this up, you get a complete torus, okay? Completed. Okay, you can actually play animation. This is a fantastic feature of Wolfram language. And while it plays, you can, let's say go back and forth, okay? While it plays, you can rotate it. Wait, can you? Yeah, you can. What? Wait, stop. I cannot rotate it. I don't know if that's because I'm limited to one CPU or something, but I think, I'm not sure normally if you can rotate it while it's doing it. It should. Yeah, I think it's, let's check my GPU usage. Do I have enough juice? If my machine is powerful enough. Yeah, my machine is powerful enough, but okay, stop this. And also let's rotate both of them together. Okay, but stop. Let's change your perspective, okay? Okay, enough of that. Let's go on next. Am I still alive? Check. Video check. Voice check. Good. Okay, so what is the... Okay, so now the next thing Okay, so yeah, watch this carefully. Okay, I'm gonna explain what you mean by arbitrary shape domain. Okay, so you see, it's a rectangular patch and match. So you can observe the shape of these things. So you see, so when you plot, so for example, you can have that. This is what you get. Essentially, it's warping a rectangular patch. But now look at this torus. This one is not like that. Completely different. You see, the equation is exactly the same. Okay. For example, let's copy the equation here. Let's copy it. Okay. Then let's select this part, delete it, and paste it. You see, the equation is exactly the same. But however, you get this thing. Why? Because we are no longer doing a rectangular patch. U from 0 to something, v from 0 to something, that forms a rectangle. But this time, we are saying the u and v are here. Okay, let me clean up the syntax here so you can see what's going on. Okay, so this is I cleaned up the syntax. So you see, the u and v here is different here. Instead, here the u and v are actually just inside a circle disk. Okay, that's how you get this. U and v are inside a circle. Okay, so I think that's it. That's it for that. Now, instead of disk, can we try something else? Let's see. We can try a triangle. Actually, we can. Let's see. It's not so interesting though, because why don't we do something else? I think, yeah, why don't we, next time when I found some other interesting feature. I mean, the point I want to make about this is that you can do parametric plot in Wolfram language. However, it has the feature where the domain, the input parameters, needs not just to be a rectangular patch. You can specify any region, any shape, triangle, circle, or any even whatever lake, shape. And to do that, all you have to say is this part. Okay, let me show you this part. Element uv. So this function, this element uv says that u and v is inside this disk. This disk is centered on 0, 0, and with a radius of 3. Okay, so if we increase the radius, it's going to plot more. So essentially, it completes. So if we decrease the radius, let's say 2, then you get this. you get this thing. So that's an interesting part. Now there's another thing interesting. You see, the patches on this torus is no longer rectangular. You see, over here the patches are rectangular, but here it's not. I can tell you why it's not. Okay, so, and I can tell you how do you implement this function. Okay, now do you know how to? Now you should be able to know, if you are a programmer. Okay, you guys, Python or whatever, JavaScript, you should be able to implement a parametric plot. Not using GNU plot. You can actually implement yourself. You can you can use it JavaScript and SVG. Yes, you can implement yourself. Just like I explained, if you paid attention, just do just compute a bunch of u and v, then feed them to the 3 functions, then you got a point. Okay, once you got lots of points in space, you need to connect them. You need to connect them in forming into polygons. Like here. Okay, how you connect them? That's easy, because okay, let me explain how you implement this normal parametric plot. Okay, So you again, you start with a rectangular patch. Okay, here's U and here's V. So you draw a grid, not grid, but lattice point. So U from 0 to 10, like 0, 1, 2, 3, 4, and V, same thing. So you got lots of points on the grid. Okay, so this grid essentially is kind of a matrix or nested list. Okay, nested array or whatever, depending on your language. So you got a bunch of two-dimensional points. Okay, then you map these three functions x, y, z. Okay, do I make it clear here? You map this function. These three functions, f1, f2, f3, into this bunch of 2D coordinates. Then what you get is a bunch of. The result is a nested list of three-dimensional coordinates, points in 3D now. So essentially you got the same structure, nested list or matrix, depending on how you view it. So you got the same structure, but now each point is now three-dimensional point. Then you have to plot it, okay? Then you have to, you got these data points of the surface. How do you actually show it as a surface? Well, that's when you need to draw. Okay. That's when you need to know some linear algebra. Okay. So basically, essentially, you need to project your three-dimensional points into a two-dimensional plane, so you can actually see it. That's what we are seeing. So you see, this torus is in three-dimensional space, but my screen is only two-dimensional. But how do we see it? But you project it just like camera, okay? Just like a camera. So anyway, that's how you implement this thing. Now, in the case if you begin with a arbitrary region that's not rectangular, then our previous method doesn't work anymore, because it's not just a grid. It's not, just U and V, rectangular grid. Now you just have like arbitrary shape. You cannot, it's not a nested matrix. How do you do it? So essentially what you do is you generate a lot of random points inside that region. You can do, you generate a random point and check if that's inside the region. So if the region is a circle, that's very easy. You can easily check if a point is inside the circle or not. Let's just use a circle as an example. So you generate a bunch of random points and check if they are inside the region. If they are, keep it. Okay. So what you end up with is a bunch of points inside the region. Then the next step is that you want to triangulate this bunch of points to form a mesh, okay, two-dimensional mesh. And after you do this, you get a structure like a matrix structure, where each triangle is 3 points. Okay, so anyway, the high-level thing is that you just start with the random points, okay, bunch of random points inside the region. Then you triangulate them. You need the algorithm to, given a bunch of random points, how do you triangulate them? That is, connect nearby points by a line. So you have a bunch of triangles like that. Once you have that, then again it's very simple. All you have to do is just map these three functions to that structure. Like the map function in Python and so on. but the map in Python and JavaScript, they cannot do that because they are idiotic. They can only do simple list, one-dimensional list. When your list is nested list or matrix, the typical Python, Golang, Perl, whatever, this industrial language crap, including C, C++, C#, Java, they fail. Because their notion of list is typically array flat. They don't have functions to work on, to map to the leaves of a matrix or the atoms of the matrix or any arbitrary nested list. So that's another power of Wolfram language, which allows you to do that. So we are talking about implementing this parametric plot of a of a given region. Okay, you don't have to. I mean, it's built in Wolfram language, but if you are curious, that's how you implement it. Okay, so now I need to take a break. So I talked for 50 minutes now. So the next thing I'm going to do is to write a Emacs major mod for Wolfram language. Okay, so let's so we've done the first two parts. The next part is write a Emacs major mod for Wolfram language. Okay, let's do that. Okay, let's do that. But give me a minute break. Okay, any comments? Comments, guys. I got money, fantastic money. That's those live donations are my primary income from YouTube. About maybe $20 a month, and mostly from the live donations. Thank you, guys. The ads, they don't get me nothing. Okay, now let's get serious. Let's do Emacs Lisp coding. Emacs Lisp coding to write a Wolfram language major mod for Wolfram language. Why do I need to do that? Because the Wolfram notebook, despite all the great features, it lacks one thing. It's not very. For example, Emacs and Vim are known for their power of manipulating text. You can move to arbitrary positions very fast. You can delete certain specific part of the text very fast. But in the Wolfram notebook, they don't. I cannot do that. You have to essentially type everything sequentially. It's a pain. So maybe possibly sometime in the future, possibly I can help. I can help Wolfram research add that feature. So Wolfram language, Wolfram notebook is gonna be XahFlyKeys notebook. I don't know, but anyway, so for now, since I code Wolfram language a lot, I want to create a major mod, so I can just type everything fast with completions, with templates for all the functions. For example, it's very tedious. You see, you have to type the whole thing. Next time I can just type PP, parametric plot, PP3 means parametric plot 3D space, it'll complete the whole thing. So that's what I'm going to do. Okay, let's begin. Let's not talk too much. Okay, so you go to my Emacs tutorial, Emacs Lisp, how to write a major mod. Okay, this section covers everything for beginners, so you can start to write a major mod. So that's what we are going to do based on my own tutorial. So let's begin. So what are we? So write a major mod for Wolfram language. Okay, so where do we begin? So first of all, I need to go to my Git directory. So you are seeing my XahGit home directory, and let's hide the details so you can see a bunch of my packages, all my Emacs Lisp packages. Create a directory. So create a directory. This gonna be called Xah Wolfram Lang mod. Okay, so here is the directory we just created. Okay, so is that right? Yeah, Xah Wolfram Lang mod. Open it, empty. Okay, now we're gonna create a new buffer. Okay, save it as Xah Wolfram mod.el. Okay, go to the directory. There it is. Okay, open it. Then we start to code Xah Wolfram language mod. Okay, so first of all, let's just copy the whole thing here. This is my tutorial how to write a major mod. Okay, so no comments. So I need to do this quick. Okay, so I guess no comment. Then it's just myself then. Okay, so then I'm just going to do this. Okay, Xah Wolfram Lang mod. Major mod for editing Wolfram language. Okay, Now, in order to do this, it's best if I look at my XahFly keys mod, because so you see this is my XahFly keys major mod. Well, actually, let's look at my Emacs list mod because that's more similar. So describe key space E. So you can see here is my Emacs list mod source code. Open it. Okay, hold on a second. So let's close the XAH list mod. Let's close the what? Okay, so this is my Emacs list mod. Copy it, close it, paste it here. Okay, so we're gonna modify essentially starting by copying my Emacs list mod. Okay, so first of all, rename. So whenever there it says Emacs list mod, change to wolframlang mod. Okay, first of all. Okay, then Wolfram Language mod, a major mod. So delete that Wolfram Language mod, major mod for editing Emacs list. That's right. So also, let's shrink it a bit. Okay, so date 2001 by XahLees and blah 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 version, fantastic version 1.0 something. Okay, 1.0, let's say 0. Create date. Okay, package requires Emacs 23, 24. Yeah, 24. Okay, it's good enough. Lisp languages, keyword Lisp languages, Wolfram Lang. Okay. And Mathematica. Okay. License, fuck GPL. You know, they do me not so good. Let's remove it for now. I'll decide what license. Probably free. You know, probably open source. But I don't want to. You know, I don't want to give it to the Free Software Foundation. They're being harmful. Homepage. Okay, I don't have a homepage here yet. Okay, let's just say that. Okay, the file is not part of GNU Emacs. The fuck the GNU Emacs template. Okay, let's keep it. Commentary, major mod. So let's start the code. Okay, let's remove this bunch of crap. Let's worry about them later. So first of all, define the. You know, let's get to the interesting parts. Writing a major mod. Okay, requires list mod. Do I require list mod? Not really. Okay, anyway, let's so I'm starting to write the mod. You see, right now there's a lots of things here, and what I want to do is actually just tell you the interesting parts instead of me tediously going through the whole. So the first, let me tell you what we need to do first. Okay, first of all we need to generate the 6,000 built-in function names in Wolfram language. Okay, let's do that first. Okay, we may not be able to finish this mod, but that's a beginning. Okay, so first of all, generate. Let's see 07. Okay, let's see. Let's you know, Wolfram notebook is just like OGMod. You can have title and subheadings and so on. So style, subtitle, O2, chapter, subtitle. What I want to do, subsection 06. Okay, subsection 06. GENERATE or Wolfram Lang keywords. Okay, function names. Okay, so the way you do that is you can just type question mark asterisk. Oh, okay, so then my God, you got to get a whole bunch of things. Okay, this is huge. So this is about 6,000 Wolfram language keywords. I need to put it in Emacs Lisp. Okay, so but before we are able to do that, let's delete it. We need to find out what the full syntax for question mark. Okay, I want to find out the full syntax for question mark. Okay. Okay, so it's not, I remember it's info something. Okay, so let's show all functions starting with INF. Okay, so I believe that's a function. Information expression gives information about expression. Okay, so what I'm saying is that the question mark name, for example, let me show you. Okay, so this syntax question mark some name display the help, the help documentation for that function. Okay, but what is the question mark? That's just a syntax, right? But however, in Wolfram language, remember it has a syntactical layer systematic. So everything has a function name full version. Okay, so what is the full syntax, the full function name for the question mark shortcut? That is information. Okay, for example, let me show you. You see, that is that one. So for example, now we can do, instead of question mark parametric plus 3D, we can say information, then bracket, then a string. Okay, parametric plus 3D. This is the full syntax. You see, this is the actual the code standard form of this question mark shorthand in Wolfram language. Okay, so now we got information. Now I need to look up what exactly the information returns. For example, we showed before. If you just type that, it returns all the 6,000 function names. But however, I need them to output in a string form, in a string, not the pretty display table column and stuff, so that I can, once I got the string form, I can copy it to Emacs. So, but in order to know how to do that, I need to know the details of the information, here. So the help that returns, that tells me what it returns. How do I control it? Okay, so let's see, 6 people. Okay, so information give information. Okay, detail information expression properties gives a list of available properties. Okay, pattern something. The special input from that, you see, we talked about question mark symbol name hides information other than the usage. Okay, so for symbol input, the following properties may be included. Okay, attribute, we don't care about that. Okay, let me just try something. Okay, because if I try to explain everything, we will never finish. So my goal right now is to get all the 6,000 functions in Wolfram language in a string form, so I can copy to Wolfram language. So I can copy to Emacs this. For example, if I copy this, I'm not sure what you get. So let's try. So open a new buffer, paste it. Okay, so you got this, formatted thing. So let's see. Let's change it to raw. Control Shift R. Nah, it cannot really do that. And yeah, so it generates a kind of a formatted way. So anyway, I want to see. Okay, that's short. So So what is the output? The output. So how do you control the output? So, okay, I have to read this a little bit in detail, okay? For symbol inputs, the following properties may be included. Okay, up values, options, supported data object expression type includes, okay. Supported system object expression types includes. Okay, supported machine learning object expression types includes. Okay, so you see some of the machine learning functions in Wolfram language. Okay, so information display just the usage message. Get the attributes for sign. Okay, get information about specific data being. Okay, so there it is. Let's see, names gives a list of names of symbols that match the string. Okay, I think so. That's a better function. Let's use that. Names. That's what we want. Okay, this is what we want instead of the fancier info. So now we just say names, a string, asterisk, that returns all Wolfram language's symbols, okay, built-in functions. Okay, so now we can see how many are there. Okay, so let's go to the top. Yeah, why is it not going to the top? Okay. Okay, so you have to, let's just press the up. So names, so let's say length, okay? There it is. So as a Wolfram language, what version do I have? As a Wolfram language, Wolfram desktop. About Wolfram desktop, I don't want to show it because it might show my license numbers and so on. But I'm on the version 12 or something. But anyway, as of this year or last year, there are 7,082 built-in functions in Wolfram language. And in Wolfram language, everything is just a function. Okay, so there's you can consider that is all Wolfram language does. Everything is a function. There's no special. Anyway, so we have okay, so let's write this into a file. So let's see if this works. Text, okay, let's just do it. There it is, fantastic, it's done. Where is it written to? Shit, is it desktop? Fuck, fuck. Now I don't know where is it written to. It might be written to in some Wolfram home directory. So okay, so let's try this again in a different let's try this again here, because this notebook is already saved, so it should save to the current directory, I believe. So do it now. Go to desktop, refresh. Okay, I don't know where is that file written to, so let's forget about that. We can look up what? Python. I started some feature about with Python integration. Oh my god. Python, not JS, SQL, JDBC, Julia, R, Ruby. Well, hey, wait. I pressed some key by mistake and I got this. So does that mean I can I'm running Python? Let's try some Python syntax. Print 3 plus 4. Start external session for help configuring the Python evaluator. C. Configure Python for external evaluator. Okay, so there's a Python integration and a bunch of others. Python, Node.js, SQL, and Julia. Julia is a great language, okay? And R is not good. Ruby is pretty good. Okay, so interesting. So anyway, what I want is actually this. So let's copy that. So now back to Emacs. Let's go back to what is this untitled, close. Yeah, Wolfram Language mod. Okay, so let's define var. Let's not require this mod. Okay, let's ampersand words functions. Okay, delete that. Okay, open a new buffer, paste it here. So here are all the Wolfram language keywords. Okay, now I want to make them each one by a line by itself. So replace quote comma by quote return quote. Do it. Okay, there you have it. So there are 7,000 something. Okay, and also this thing is Wolfram Language's way to continue a line. So let's delete that. Okay, good. So 7,000. So and fantastic. Okay, and we don't need these characters. So we delete that. You know, there's a lot of these characters, so we delete that actually. Delete that. Okay, delete that. Okay, delete that. Okay, so A also delete that because okay, A is not actually built-in. Okay, so now we have a list of all Wolfram language keywords. Okay, let's go to the bottom, and then you have a bunch of $sign ones. Okay, let's keep it. Okay, now copy the whole thing. So we change them into a list. Okay, so now you see some of them has a comma, trailing comma after it. Some of them does not. All of them should have one. Okay, so in order to fix this, all we have to do is find and replace is your friend. You know, the reason some of them don't have the comma is because I deleted it by mistake, you know, before when we replace the slash or backslash. Okay, there you are. There we have it. So here now we have the 7,000 functions of Wolfram language. We want to basically copy the whole thing and paste it here as a list. You see, here is a list. XAH elist functions. So this should be changed to XAH Wolfram functions. Okay. So list of Wolfram language. Okay. List of Wolfram language functions. Okay, let's delete that. Okay, a list of Wolfram language functions. Then here is the real list. Let's delete them. Let's that, and let's paste here the whole thing here. Paste. Then remove the the bracket. Okay, let's delete that. What? Yeah, so there it is. So we define the function. Okay, this is kind of long, big ass long function. I mean very many lines. Okay, so we are writing the major mod for Wolfram language. Let's continue. So what else do I need? I don't need this. I don't need this. I don't need this. No need. Delete map atoms, whatever. Delete. So we have completion code for completion. I don't know. Delete. Let's worry about those later. Okay. Now let's shrink so you can see what are we doing here. So basically delete all these functions. Now abbrev I want. Okay, abbrev XahWolframlang mod abbrev table. That's what we want, abbreviation, because abbrev give us function templates. Oh, finally, someone says something. But don't even bother. Running Python is almost as hard as getting an audience with the Python is one of the most popular language today because of Google. Okay, so abbrev we want, but we need to rewrite all these abbrevs. Okay, so let's you see this thing. Let me show you. Okay, so you see each one of this line, they are for Emacs Lisp. So this function, for example, will expand to the full syntax of that function. So this is very useful, and I'm going to do this for Wolfram language as well. So you actually need to find the templates of the function you use frequently, you want to abbrev for. So for example, in Emacs Lisp, if I type C, it expands to concat. If I type D, it expands to defun. Now these single letter abbreviations are the most used functions in Emacs Lisp. So I for insert, so we are going to do similar for Wolfram language, but for now let's delete them. So okay, so also delete that. So we just want we start with the basic template. Then Emacs Lisp command name, command face, delete. Okay, faces, we don't care. Emacs Lisp symbol, let's forget. So these are about defining the font, color of the font, syntax coloring. They define special format of the keywords for my Emacs Lisp mod. So I don't need them. I might add them for Wolfram language later on, but wait. What did I delete? Okay, delete. This we want. So XAH eLisp font lock words. Yeah, so font lock. So first of all, change all eLisp to Wolfram. Yeah, so change all Emacs Lisp to wolframlang. Okay. What? Okay, I did a lot of changes. Okay, so anyway, the package now, I hope to get to a state, we can reach a state where I can actually start a package, show you some of the most simple, show you it actually works. So, okay, so in order to do this, I'm under heavy pressure, my friends. Okay, so let's define a simple abbrev. Okay, let's say PP3. Okay, PP3 will stand for parametric plot 3D, like the way we used today. Why we have another elisp here? Let's see. Oh yeah, change, okay. Change, okay. So actually this is, so parametric plot, so PP3 is parametric plot 3D. Then we need to have the template for parametric plot 3D. So okay, I'm gonna show you how to write that. I'm gonna write here, right here. So parametric plot 3D sign. Let's say this. Okay, yeah. Let's say F1. Okay, F1, F2, F3. So we have three functions. Why is it not? So we have three functions. Then we need two parameters, U, A, B. Okay. U min, U max. Okay, let's just say A, B. Okay, so that's the beginning of the template. This, okay, copy that. So put here, then remove that. Then we need a cursor. Let's put, where do we want to put the cursor? I don't know. Let's say here. Okay, then this part you don't need. Okay, so that's it. That's it for this brief. So we have two briefs. PP3 stand for parametric plot 3D. It will expand to that. Then parametric plot 3D will expand to, with arguments template. Okay, then whatever that. Okay, so this is getting long. I need to work on this Wolfram Language brief table. Okay, so those are specific details about a brief. Then syntax color related. So this is how syntax coloring works. Yeah. So actually you don't need that $symbol, add symbol, cap vars. Okay, don't want that. Okay, so then ampersand words, no, we don't need that. Then what is this Wolfram function that we want? Okay, so that we want this, no, this macro, no, commands, no, user options, okay, user options, no. Okay, I need to just to get it to work now. Okay, so I'm just gonna code this quickly. Font lock built-in face. What is this? Okay, delete that. Clean, prettify. Okay, so that's that. Now syntax table. Oh my god, fuck, syntax table. Wolfram Lang mod syntax table. Okay, what syntax table should I want? I know that let's have none. Okay, none of this shit. You don't need any syntax, no special syntax table. So syntax table, make syntax table. Okay, no no inheritance, okay? Not gonna be based on. So Wolfram language syntax table is just a syntax table based on fundamental mod, meaning there's no special thing. Because Wolfram language is, rather different from, the syntax is rather different from all the industrial languages. Then key binding. Okay, key binding is important, very important, but we worry about that later. Okay, so tab for completion. Yeah, we want that, but actually we don't have. We don't actually have a function to do completion. Yeah, but we need to. So shit. So I need to write that function. Completion. But okay, let's comment out for now. Let's not worry about this too much because I do this later. Right now my only one goal, let's say, is just to create a Wolfram language mod so that when you show a Wolfram language source code, it will syntax color or built-in functions. Okay, let's just say that. And also, let's say a brief and template. These features, nothing else. Okay. So wolframlang add paren around symbol. No. Prettify root expression. Yeah, we need that, but okay, but let's comment out. Remove paren pair. Okay. Yeah, we need that. Compat paren. Okay, so and wolframlang complete symbol. Yeah, we also need that. Okay. But for now, nothing. So imenu, okay, imenu. I don't want no fucking imenu. What is imenu? The imenu is a Emacs thing. When did I add imenu to my Emacs list mod? I don't remember I did because I don't use it. So anyway, delete it. No imenu crap. Auto load. Okay, here's the main part of the mod, defining the actual mod. Okay, so auto load define derived mod. Yeah, based on programming mod. Okay, then Wolfram Lang. Okay, so let's make them a bit short. Major mod for Wolfram language. Okay. So this documentation, let's ignore for now. Okay, documentation ignore. Okay, then font lock defaults. Yes, we want that. Yes. Comment starts comments. There's no such thing. I mean, in Wolfram language, the comment is nothing. It's like a Haskell's. Okay, there's a matched parenthesis. Pascal, actually, it's the same thing used as a Pascal comment. So yeah, so that's a good idea. So I can actually borrow the syntax table for Pascal language mod when we work on this. So comment delete. So imenu. I don't want imenu. So indent line function. Yeah. God. Yeah, what are those? No. So what is this? So when calling Emacs complete symbol follow convention, when press tab do XahTV. Yeah. Let's worry about this later, okay? I don't know what is that. Make local variable. Okay. Oh, God. Display page breakers line. No. Pretty symbols at least. No. Version. Yeah, okay. Okay, group at least auto mod. Okay, Wolfram language mod is .m. Okay, also .mb. Okay, let's see that. Okay, so that's the end. Now let me show you the structure. Okay, so the the structure of what we have so far of this source code. Wolfram language mod, major mod for Emacs lisp for Wolfram language. So the first, the first 7,000 lines are basically Wolfram language, the keywords. Okay, so let me show you here. Okay, so paste it here. You see 7,000 lines. Now I'm going to compact this. Shit. I don't want one single thing, this is what I want. I want to compact them so that, so that you don't have to scroll 7,000 lines to see, So now it's just 20,000 lines, okay? Yeah, so make sure the syntax is correct. Now, can we actually evaluate this, make it into a list? Let's see. Yeah, so the syntax is correct. So, okay, cut it, then just paste it here. Then you don't need this part anymore, okay? Yeah, so let me show you the structure of the source code so far. So we have, the first, this is a long Wolfram language. Okay, so the first 2,000 lines is all Wolfram language keywords. Okay, and they are named Wolfram language functions. Okay, let's search for that. Okay, so copy. Then a brief. We define a brief table variable. Then we define, what is this? Yeah, then we, okay, then we define basically two abbreviations. Okay, then we have Wolfram Language brief table, then enable function. Yeah, we need that enable function. Okay, because without this won't work. So let's get back to my XAH Emacs lisp mod to retrieve that function. So here, XAH elisp abbreviated enable function, we need that. Okay, so this function, okay, so that's a function. Let's put it here, and let's copy the Wolfram, instead of elisp, say wolframlang. Okay, okay, so we have that function. Good. Now next, syntax coloring related. Let Wolfram font lock mod. Okay, that's good. Then rejects opt Wolfram functions. Okay, XAH Wolfram lang functions, it's not found. Let's go to the top. Why is not? Oh, so okay, so instead of Wolfram, now we have Wolfram lang. That's inconsistency. So yeah, so change all Wolfram lang to Wolfram, basically, essentially. Okay, so copy, you need that. Okay, let's find and replace Wolfram lang, change to Wolfram. Not that. yeah, do that, do that, do that, do that, do that, do that. No. Okay, actually. Okay, so actually. Okay, so let's rename all Wolfram Lang just to Wolfram. So rename the package. Now instead of Wolfram Lang mod, just say Wolfram mod. Okay, so because otherwise our functions are too long. It might be it's simpler just to have, simpler. Simpler is good. Instead of Wolfram Lang mod, just Wolfram mod. Okay, so do we have any more Wolfram Lang? Yeah. Oh, okay. So this. Okay. Yeah. So good. So yeah, Wolfram. Yeah, because Wolfram has many products. Wolfram Alpha, Wolfram Language, Wolfram Mathematica. So it makes sense to have Wolfram for all Wolfram stuff. Kind of. It's good enough. So Guillermo says, where can I find your extension? What extension? You mean the Wolfram mod? I haven't put on the GitHub yet. Hello, Jack. Hello, Jack. Jack, I need to talk to you. I need to go to the Chinese video. I need to start to do it. I mean, I know I talked about that long time, but okay, yes, I'm gonna contact you. Okay, from WeChat. Help me out on that. Okay, so this is getting long. Now I talked for how long? So this video is 1 hour and 40 minutes almost. Yeah, but we are doing a lot of things. So essentially this major mod is done. Let's look at one more time. Okay, so the first Wolfram functions, let's search for that. Yeah, so that's good. Yeah, so the first 2000 lines is basically a list of Wolfram language function names. Okay, there are 7,000 of them. Then Wolfram abbrev enable function. Yes, we need that. That's for abbreviation. Then Wolfram mod abbrev table, we need that. Okay, this is for abbreviation. Okay, so this is abbrev part. Then we're gonna add, right now we just have 2 abbreves. We're gonna add like about probably 100 later on. Then and probably not 7,000 of them, because 7,000 functions. It would be nice though, but I don't know. Then syntax color related. Okay, so this part is syntax coloring. Then syntax table. Yes, this part we do actually need. Okay, so let's test something. I want to go to fundamental mod. So in fundamental mod, if I have, does this oh shit. Let's see. Text mod. Okay, so actually I need to back to Emacs this mod. So actually I need to add some syntax table for the double quote, so that they become strings. They become highlighted as strings. So how do you do that? Go back to Emacs tutorial, writing a major mod, then you go to syntax table. Okay, syntax table is very painful to work in Emacs. Emacs syntax table is a pretty bad idea. So how do you add a syntax table for quotes? You know, double quote as the double quote as the you know, the delimiter for a string. I don't know. I'm trying. Let's go to XahJavaScript mod. So cheat and copy and paste. Okay, so let's look at my JavaScript mod. Okay, actually, let's look at CSS mod because it's easier here. Let's see syntax table. What? Where's syntax table? Oh, there it is. Okay, so you want syntax table. Shit. What is a string for syntax table? Yeah, string delimiter double quote. Okay, I guess it's here. No, it's not. Wait, why is that? What? Okay, quote should be already. Let's ignore it for now. So now again, so syntax table, let's ignore it. And key binding, we also ignore it for now. Define prefix command. Wolfram mod map, Wolfram leader map. Okay, Wolfram leader map, define prefix command. And Wolfram mod map. Okay, that's good. And then we have the main definition. Define derived mod. Okay, XAH Wolfram mod. Okay, based on programming mod. Okay, good enough. And the short name will be, let's say, capital W, and let's say lowercase or lowercase. Okay. It's capital. Okay, so major mod for Wolfram language, and then double check, make local variable. Okay, then blah 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 blah. What is this? Do we have it? Wolfram, XAH Wolfram expand abbrev. We need that. Okay, we cannot find it. Yeah, so we need that function. So let's look at the XAH Emacs lisp mod to find that function. Okay, there it is. Search for it. There it is. Copy it. Oh, okay, so this is XAH lisp expand abbrev. Expand the symbol before cursor. Okay, so this we need. Copy that, and we need to go back to the abbrev section and paste it there. Okay, paste it here. Yeah, and also change the name from elisp to Wolfram. Okay, so now we have the function defined. Let's change the version date. Okay, got that. Yes. Now abbrev mod, turn it on. Now if version is less than Emacs 25, make local variable and so on. Yeah, that's I mean, I do separator. Okay, okay, I think that's it. That's the Wolfram language mod, the draft version. Now, my hope is that if I run it, then try it, it will work. Okay, my style of coding. No trial and error. One shot. And also, I don't like, let's remove the this line. Those are the control form feed. Those are invisible control characters called form feed, used in Emacs Lisp source code to indicate a section in source code. But that's 30 years ago convention, because nobody uses invisible characters, control characters in their source code anymore. You just use visible ASCII. So let's remove those. It's displayed as a line because of Emacs. I have special things to make this display a line. But this is actually, the ASCII character called form feed. Okay, ASCII code point 12. Okay, so remove that, paste that instead. Okay, so actually, yeah. Okay, so do we have another form feed? No. Okay, so save it. Turn off that. What is this? Close that. Don't save. Turn off that. So now we just have two windows. Let's make it another window. Okay. So this is the mod. So this is it. So evaluate it. Error. Wrong type argument. String P. Wolfram UUID. Okay, so we have some syntax error here. What? Wrong type of argument, backslash. Okay, there's some backslash here, error. What? I think there's a missing comma or something. Okay, I don't know. So let's evaluate this and let's see what's going on. It works. So why is it evaluate buffer? Wrong type argument, string P / comma. Okay, so I think we got a empty comma. Oh shit, I forgot. In Emacs Lisp, you don't use comma to separate values in a list. Okay, so let's copy that and let's do some surgery. So okay, so first thing we do is to make all this into single lines. Okay, so replace that by that. Okay, then we're gonna replace comma. We're gonna replace double quote comma return by double quote return, no comma. Okay, do it all. Fantastic. Now make it into, okay, so what? Make it into a, yeah, so that's what we want. So fantastic. Now copy it, close that, paste it here, delete the rest. Okay, fantastic. So now shrink, evaluate this, fantastic. Now evaluate the whole buffer, fantastic. Check the error messages, check the error message, the messages buffer. Is there any error? There is no error. Okay, so Oh, we closed it by mistake. Okay, so fantastic. Now it's working. Now make a backup just in case we fuck up. Fantastic. Now we have a Wolfram language mod. Now it's time to do unit testing. Okay, so create a file. Let's copy some Wolfram language syntax. Okay, let's see. Where is my beautiful curves? Okay, here. So let's copy this, this is Wolfram language source code. Go back to Emacs, paste it, save it, xx.m. Okay, m is Wolfram language's package. By convention, Wolfram language source code file name ends in .m. And if it's a notebook, it ends in .mb. Okay, so go to diet so you can see we have this file. This is a test file. Let's rename it test. Okay, so wait. So you can see. So we have two files. Okay, so let's open the test.m. So now we are going to. Oh wait. Syntax coloring didn't work. You see, we are already in Wolfram mod. You see at the bottom, Wolfram mod. But syntax coloring didn't work. Let's debug. But let's try something else. Let's see. PP3. Now, if I press space, it should expand to parametric plot 3D. Do it. Fantastic. Now, if I press again, it should expand to a template with the arguments. Do it. Fantastic. Okay, we are almost done. Now there's a little error. Okay, so you can see symbols function is void XahWolfram AHF. Okay, I can fix that quickly. Let's go open. Let's open another Emacs window so we can actually. So let's go to XAH Emacs lisp mod. Let's fix the AHF thing. So copy that. Okay, so do that. So now let's go to Wolfram language mod. Okay, so let's go to Wolfram language mod in a brief section. Okay, which is here. Then paste here. Then change the lisp to Wolfram. That's good. Okay, so that's good. So that fixed one problem. Now the other problem is syntax coloring. So why is syntax coloring not working? Let's see. Syntax coloring. Okay, syntax coloring not working. Why is I'm getting tired. Okay, syntax coloring, that's called fontification in Emacs. So where is it? So it's okay. So function names, then abbrev, okay, then coloring related. Okay, so here XahWolfram functions, for somehow they are not rejects opt. Okay, I don't know why is the it's not. I don't want this fucking complex shit. Okay, now evaluate the buffer. Oh, wrong type of argument. Wait. Wrong type argument. Lisp p font log function name face. Okay, so Okay, so actually, yeah, fuck. This is pretty, okay, let's look at my tutorial, Emacs Lisp tutorial. Let's look at the syntax table, major mod naming, writing a major mod, syntax calling, font lock mod. Now there's a special structure when you define, let me explain, okay? So you see this set q font lock defaults. The value is basically a list, a nested list. That list essentially tells Emacs how to syntax color the buffer, okay? Now, however, that list needs to have a special structure. And I think what I have done is I fucked up the structure somehow. Wait. That should work. Why is it? Evaluate. Okay, no error. Let's go to messages. Evaluate, no error. Now go to this, close it, reopen, no color. What the fuck? Let's search for parametric. Let's do a string. Okay, string is colored. String is colored. Fantastic. But why is the parametric 3D not colored? You know, built-in function should be colored. Also the word element and also the word disk, I mean here, and also the word directive, you know, the word plot points, max recursion, and so on. So okay, so I don't know. So okay, so before we do anything, let's just quit Emacs. You know, this today is 2 hours talk. Quit Emacs and restart. Maybe everything will be better. You know, it's like when you have a problem, just go to sleep. When you wake up, everything will be better. So much for one shot. but I'm close, you know. There it is. Fantastic, guys. Look. But one shot, now syntax coloring is back. It's not working because, you know, the variable is messed up because I did multiple evaluations, you know. So now, welcome to the Xah Emacs Lisp mod. Okay, there's something else wrong. You see this smart line? It says object C. Like, what the fuck? What? Close. Go to the, okay, let's magnify. Okay, so go to settings. Let's magnify the font. So because otherwise you cannot see. 16. Evaluate. Okay, that's better. Close that. Okay. Now close that. Okay. Wolfram Language. Okay. Now open the test. Close it. Open the test again. What the fuck, Objective-C? On one hand, it's showing Objective-C. On the other hand, it colored all the Wolfram Language keywords. Wait, only some of them. What the fuck is Objective-C? Now let's open the Wolfram Language mod. We haven't evaluated this buffer yet. So let's evaluate the buffer. Okay, now go to test open. Okay, now it's Wolfram mod. Yeah, it's not coloring. So is there any error? Okay. Oh, okay. So you can see we reached a limitation of Emacs Lisp. You see, error during redisplay. JIT lock function 1 signaled. Invalid rejects regular expression too big. Regular expression too big, my friends. That means our Wolfram language, the 7,000, the 7,000 functions is too big for Emacs to handle. What the fuck? So one solution immediately is to split the these 1,000 functions. Okay, let's just split into two, then do two rejects. Okay, so that's what I'm going to do. So let's do it. Okay, so let's show you Wolfram now I've been sitting, coding, and talking for 2 hours now. Oh shit, my drink is dry. But what you doing watching my videos all day? I mean, it's late for you. Don't you go to work? Wolfram $sign. Okay, so dollar names. Okay, dollar names. Wolfram dollar names. Okay, so delete that. What? Oh, okay, actually I fucked it up. What? Oh, I fucked up some parens, I think. Okay, so set Wolfram dollar names that, okay, that, then cut that, okay, that. Okay, so we got mistake. Yeah, so okay, so I split part of the 7,000 into dollar names. Then I don't think that's enough. Still, okay, let's split again. Okay, let's do this quickly. God, I'm just gonna do it. Okay, so. Okay, so there are 6,700. So half of that is 3,400. Okay, so let's go to 3,400. Let's say 4,000. Okay, so after 4,000, then n start a new one. Okay, so Nakamaka distribution. So let's do this. Copy, do it here, paste it here, do it. Okay, so this Wolfram functions 2. Okay, functions 2. Okay, then that's going to be everything starting with n. Okay, so n to z. Okay, so there it is. Paste it so you can see what we're doing. So we split the Wolfram functions into two. Okay, so functions, let's rename it to 1. Okay, do it. No, 1. Okay, let's see, then copy this line, copy functions 2, then another one, dollar names. Okay, so you see here, Wolfram functions 1, 2, and dollar names. Okay, I'm getting tired. So now make a backup, evaluate the whole thing, check the error messages buffer. Is there any error? No error. Fantastic. And now go to diode, open the test page, close it, open the test page again. Nothing. No colors. No, it's not color syntax colored. So look at the error pages. Shit. Emacs limitation. Error. Regular expression too big. Okay, so 4,000 functions is still too big. What the fuck? I remember it should be able to handle it. Let's go to Emacs lisp. Let's go to my Emacs lisp mod. How many functions I have in my Emacs lisp mod? So I do remember I also have to split it, but elisp functions. Okay, let's copy it, new buffer. Okay, only 14,000. 1,400. Okay, so in Emacs lisp we reached a regular expression error, talking about something like too many regular expression too big. We can, I'm pretty sure we can solve the problem by splitting again. So let's try one more time. Split the functions into more. Okay, what is this? Okay, close that. Okay, I'm just going to do this quickly. Okay, make a backup first, then this functions 1. Okay, functions 1 to okay. Okay, first of all, new buffer, make it into a, okay, so where is the middle? So 1096, so about 500 of them. So E, so let's split. So D and E, okay, so let's split D and E. Okay, so now shrink, let's go back to the mod. We need to split D and E. Okay, function 1, function 2. Okay, function 1, function 2, and function 3. Okay, let's get the structure right first. Function 2, function 3, functions 4, and set. Okay, that's what you need. Then set. Okay, that's what you need. Function 3, 4, and the function 2 actually needs to be moved to function 3. Okay, paste it here, and function 1 needs to split starting with E. Okay, earth. So search for earth. There it is. So starting from here to here. Okay, cut. Then there, function 2, Then function 3 also needs to be splitted. Okay, now where do we split? Let's see. Close that, new buffer. Now copy the function 3, copy back to here, paste. Let's see. So there are a total of 740, so about 400 or 300. Oh, there's only 740 now. Now it's simpler. 740, Emacs can handle it. We don't need to do anything. Close that. Okay, so wait, I don't think so. Yes, because 700 lines, but each line has 5 names. So that's gonna be 3,000 something. Okay, so better to split it. So let's split it. Okay. Okay, I'm getting hot and I'm getting tired and okay, so there's a comment. Let me read it. Okay, so this 700 lines. So let's go to 400. So 400 S. Okay, so let's start with S, shall we? Fuck. Okay, right here. There it is. Okay, so we split into 2. Now the first part, so start with same text. That's the third one. I mean, that's the third, the fourth one start with same test. So search for same queue, not same test. What? Search same queue, okay, here. So starting that, go down, cut, okay, then put it in this number 4 list, okay. Okay, I'm tired. Evaluate the buffer, go to the error message, no error, good. Make a backup, close it, open our test file, close the test file, open it again. Beautiful. Now we see some of the functions are now colored. Some of them still not. And I suppose the same error. Regular expression too long. Fuck. So we are seeing the limitation of Emacs, regular expression too long. Now, so parametric 3D is not colored, so it's so we can find out where that function is. But basically we solved our problem. Regular expression too long. Okay, let's see the comments. Tanner says, it looks like you need to add performance score quality to your code to parametric plus 3D inside the manipulate to not get the ugly effects. Oh, okay. So let's see. Thank you for that. You are a Mathematica coder. So we have an expert giving me opinions on this now. So saves me time from half an hour reading of this. So let's try that. So he says you need to add performance score quality. Okay, fantastic. Now I believe that's an option in manipulate. Yeah, so let's so that here performance score. Okay, wait, is there something wrong? Wait, why is that not allow me? Spelling error. It's probably a spelling error, but I do take the pen to actually check. Why is it? It's not spelling error. I have no idea why is it doing that, but okay. So let's just continue. That's strange. We should look into. Performance score, okay. Then quality, okay. Do it. Wait, why is it? No, it's an option to parametric. Oh, that's why. Okay, so cut it. So plot range. There it is. Do it. Do it. Do it. Okay, but oh, fantastic. Thank you. So that solves the problem. Yes. So that thank you very much. Okay, so I think we done today. That's more than 2 hours long talk today. So we did, so summarize, and we close down in 2 minutes, in a minute. So we did a lot of things actually today, although it's long, but it's rather fairly condensed. And let's go to talk show. Okay, let's review what I've done. So today we talked about what is parametric surface from a math point of view, about math. What is a parametric surface? And in summary, it is a transformation from a rectangular patch, rectangular plane to a surface, okay, by these three functions. And we also showed, demonstrated a Wolfram language feature where it can plot parametric surface of any region, not just a rectangular region, but any circle or circle with hole or any irregular lake shape, any shape. And we also talked about how do you actually implement such a parametric plot function, the normal one or with any region. We explained that, how to do it. If you are interested, if you are into discrete geometry, computational geometry, if you are young and trying to learn something, so you can try to code it in JavaScript or Python to create your own parametric plot. Then the last 1 hour, we wrote a Emacs lisp, in Emacs lisp, we wrote a major mod to code Wolfram language. So as we have shown, we have parametric plot 3D. Okay, we have completion. We have abbreviation. We have syntax coloring. We still have some bugs to fix because the regular expression too long problem in Emacs lisp. Okay, that's it. Okay, yeah, paste. So YouTube does not allow you to paste links, so you have to find some other ways. Try to merge your URL or something. Okay, so or you can join Discord. We have a Discord. So anyway, thank you guys for watching. Oh, okay. So well, okay. So customized front end. Yeah, if you can, if you cannot paste it, that's okay. So thank you guys for watching. If you like my stuff, of course, donate, Patreon me, PayPal me. You can see the link on my website. It's not hard to find. Or buy my Emacs lisp tutorial or JavaScript tutorial. Thank you guys. Bye. Oh, today is like 90 minutes. Concurrent viewers now, so 8 people watching. So today we talked for, it's the longest ever. Yeah, so it's the longest I ever done. 2 hours and 18 minutes. Okay, bye.